We are here in Technopark in the middle of Zurich at Zurich Instruments. So Zurich Instruments is a spin-off from ETH Zurich. It was founded 18 years ago now. We build control electronics for both test and measurement applications and also quantum technologies, or more specifically quantum computing. I'm an application scientist for quantum technologies, and my role at Zurich Instruments is actually to engage with academic and industry partners and engage into collaboration projects. So I'm working with getting the technical requirements from our partners, from our customers, and working together with the teams inside of Zurich Instruments to build the next generation of features required for developing the quantum computers even further. I think what is really exciting for me personally is that I get to interact with people from so many different backgrounds because it's such an interdisciplinary area. So I have to interact with electrical engineers, hardware engineers, software engineers, physicists, mathematicians. I have a PhD in quantum optics, so quantum physics ultimately, and how I use this in my work, even though I'm a project manager and I'm not myself doing the research or I'm not myself doing the development of the products, is I need to understand what my customers and what my partners are trying to achieve. So I need to have this very fundamental technical knowledge to be able to communicate with them, understand their needs, and bring this to the company such that we can develop then our products further. Like in a normal computer, the processing unit has bits. These are qubits in the case of a quantum computer. And a qubit is something that usually has 2 levels of energy. And you need, in order to process some information with it, you need to be able to, we say, initialize this qubit. So this is basically control where is your starting point of your qubit. You need to be able to manipulate it, right? So do some operations with it. And then later on, you need to be able to read it out. All this control, the initialization, the manipulation, and the readout of these qubits is done electronically with electromagnetic pulses. What Zurich Instruments does is actually provide these electronic systems for controlling the qubits and controlling the quantum processing unit. Quantum computing stays at the moment in a position where we are side by side working to scale it up, so increase the number of qubits, and at the same time make these qubits better. Quantum computers will be very useful for solving problems that are very difficult for classical computers to solve, such as, for example, determining how molecular structure in a medicine, for example, is arranged, or also for agricultural chemicals, or the weather, or traffic, or finances. So quantum computer has a big power to change the world.